In the previous video we added detail to our ladder logic program to make our system work, and in this video we're going to build a visualization to test it. So if we go to the third tab along, into visualizations, right click, add an object, give it a name. I'm going to call this Vis1. The system doesn't like spaces, so don't use them. And to make things slightly easier, I'm going to copy in the little piece of graphics that we were looking at earlier. So I'm copying it in from the JPEG file. So I'm going to build my visualization on top of this. So to begin with, I need to represent these roller switches. So to do that, I'm going to add a button here. This is going to be A0, and it's a push button. It's going to act as an input, and it's a tap style. Actually, no, toggle style. F2, and it's A0. I'm going to do the same thing for A1. Click it to A1. And I will also need a push button for a start. This one is going to be a momentary push button, so it'll be a tap variable, and it is going to be a start button. And we will also need a stop button. Also momentary, so tap style, and it's linked to the stop button. And I will need to represent my solenoids. So just here, I will have this change color. In its normal state it'll be grey, and whenever it becomes active in its alarm state, let's make it orange. This is a extend solenoid. And another one here. And this will be a retract. Then its alarm state. In its normal state it should be grey, and in its alarm state again we'll make it orange. Also in here I need to go to variables and tell it when to change colour, so it should change to colour when a retract becomes active. I don't think I did that on this one, so we go back in, change colour when a extend is active. So this is a quick visualization. You can take a little bit more time and add a little bit more detail or tidy it up a little bit. But this should allow us to test the system. There's two other things that I want to add. I want to add a little text box that shows me how much time has elapsed on my timer, and another one to show me how many counts, what my actual count is on the counter. So to do that, I'm going to add something here which is linked to the timer. So I'm going to call it lapse time. And from previous videos we know that if we hold Control and Enter and add our little bit of code, %s, it'll show lapse time. And if we go to our variables area, text display, press F2 and expand the timer and take this elapse ET value, elapse time value. This will show us our elapse time. And if I do the same, on my counter, just need to close that. Go in and call this one actual count and Control Enter to the next line and %s and link it, text display F2 and here expand counter 1 and find the CV value, count value. This should allow us to test the system. So to do that we will go to, I'll drag this up slightly so that we can see our error counts. Go project build. With 0 errors and 2 warnings. The warnings I find are with reference to the 2 rungs, the timer rung and the counter rung, where we have not assigned an output. But it's not necessary to assign an output because we're using the actual Q value itself. So in this case I wouldn't worry about the warnings. If there were errors you could scroll up and find them as being red. We'll go back to the visualization. Project build, zero errors. We will go online and log in, and online and run. So to begin with, this switch is active, so we'll turn that roller switch on and we will press our start button. So you can see A extend comes on, the solenoid comes on, so that'll mean that the cylinder will start to move. As soon as it moves away from this switch, the switch will go off. You can see A extend stays on, so it's going to keep going, and then it'll eventually hit this switch. So at this stage the timer has triggered and A extend has gone. The timer reached 3 seconds and A retract came on, so that's correct for our system. So when A retract comes on, our cylinder will start to move back. So A1 will go off, and eventually when it gets to here, A0 will come on. And you can see our count has moved up 1, and A extend has come on to send the cylinder back out, which is correct, exactly what we want. So when the cylinder moves, this roller will go off, and this one will come on. And again, our timer has started, and the timer lapsed for 3 seconds. The count went up by 1, and A retract came on, so the cylinder will start moving back. So this switch will deactivate, and this switch will activate eventually. A extend has come back on, so this one will deactivate, and eventually we will reach A1. And again, our timer lapses, our count moves up by 1, and the cylinder retracts again. The cylinder moves back, and at this stage A1 will deactivate and A0 will activate. Again, A extend is on. We're moving off this switch and onto this one. So at this stage we've lapsed time 3 seconds, the count went up so that we're at 4. So at this stage A retract is on to bring us back. So that switch will deactivate and this switch will activate, and you can see that extend did not come on, which is exactly what we want. So it looks like for the first cycle everything was fine. If I press the start button, then the cycle should start again, and it does. The actual count went back to 0. So this looks okay. We'll roll off that switch onto this one. I like to go through the cycles twice to see that everything is okay. It goes off, and that comes on, goes off. It's just a simple test. And again, this is all working correctly so far. Our count is at 4. We're still in retract. So we've been through the cycle twice and it has worked. The only other thing to test is our stop button. So if we go start again and extend comes on, get to a 1, we're now at a 1 count. So if I press the stop button at this point in time, if the stop button is pressed mid-cycle, which we're in mid-cycle, then the cylinder should retract and stop. So stop. So we've got a stop and we've got a retract, which is what we need. We'll roll off that switch and onto this one, and we didn't start again, so that's what was required. And if we press our start button, everything starts up again. So we've tested the system and it's operating correctly. I will now physically build the system and test it on the hardware. So our next video will show the system being